So tonight's lecture is going to be on measurement systems. So the metric system and the US system and the conversions that follow from those. So why is this important? So the reason you need to be very competent in measurement systems, it can seem kind of basic, but it is hugely important. And I can speak from experience as a pharmacist. It's amazing what seems very basic and easy at the beginning of a 10-hour shift doesn't seem nearly as easy when you're 9.5 hours deep and you haven't really had a chance to sit down and eat anything and you have to use the restroom. So this needs to be like knee-jerk embedded in your synapses to make sure that you don't make an error such as the ones that we're going to go over here. So the first case study is an 8-year-old boy got some clonidine. Clonidine's used for a lot of things, hypertension, hyperactivity. It's kind of a catch-all drug. And a pharmacist prescribed 1,000 times the dosage that he needed. And the child immediately started having reactions to it, obviously. Yes, Derek?
I can see your screen, but it's minimized. Can you press present on that screen?
I was able to pin that smaller screen, Derek, if that helps.
Oh, okay. That's
no. Let me.
Okay.
Let me.
I got it now.
Is that the okay? So it was a presentation thing on your end. Okay.
Yeah.
Okay.
Yeah. When you pin it, it looks just like how it normally does, but it did come up funky this time.
Yeah. Yeah, I apologize for that. I don't know. It came out of the gate that way, but I mean, I'm perfectly willing to take myself down and come back up if there is an issue there. So the child got a medication that caused his brain to swell after he got 30 milligrams instead of what was intended, which was 0.03 milligrams. So as you can see, that's a difference of 1, 2, 3, 4 decimal places, or 1,000 times different. An overdosage in that case. Another instance would be a child, once again, received an overdose of an antifungal medication, diflucan, or fluconazole is the generic name. As a suspension, the physician had phoned in a prescription for diflucan at 25 milligrams per day for a 3-month-old who had thrush. So got some thrush. The antifungal medication will clear that up nice and quickly if it's prescribed appropriately. And the pharmacist dispensed 10 milligrams per milliliter. Nothing to be alarmed at yet. However, the directions, or SIG, they call it, was give 2.5 teaspoons full. Instead of, if you can see where we're going with this, 2.5 milliliters. Okay? 2.5 milliliters would have been the correct 25 milligram dose. Instead, they got 2.5 teaspoons full. And maybe you know, maybe you don't know, but there are 5 milliliters in every teaspoonful. So the child got a dose that was 5-fold too much because of that mix-up between teaspoonfuls or metric and the US version of measurement. So do not confuse a teaspoonful with a milliliter is the take-home message. So first of all, let's look at the metric system. The base units and pro-trick, something that might show up on an exam in the not distant future is what is a base unit in the metric system and what does it measure. So length, the base unit is a meter. For volume, the base unit is the liter, and for weight, the base unit is a gram. So what do we mean by base unit? Well, base unit is the unit that everything else is keyed off of. And by adding prefixes, you're able to indicate how much larger or smaller than the base unit you're talking about. So in the middle, you can see the base units for length, volume, and weight, which are meter, liter, and gram, which we just went over. And then as you go to the right, you get into fractional percentages. Each step to the right, you are a tenth smaller than the base unit. A decimeter is a tenth of a meter. A centimeter is a hundredth of a meter. And of course, then a millimeter is going to give you a thousandth of a millimeter. Likewise, you can also think of it, 1,000 millimeters in 1 meter, 100 centimeters in a meter, 10 decimeters in a meter. And likewise for deciliters, centiliters, milliliters, and decigrams, centigrams, and milligrams. So centering ourselves on the base units again and going to the left, the numbers are getting larger. So a decameter is 10 times a meter. Hectometer is 100 times. And a kilometer is, or kilometer, is 1,000 times the meter, or 1,000 meters. You've seen, if you're watching the Olympics, basically, since it is a worldwide event, everything we're looking at is in metric systems. So you run the 1,500 meter instead of the mile, that type of thing. So to move from the meter to the number of meters in a kilometer, of course, you need to divide by 1,000, divide by 100 for hectometer, and 10 for decameter, and then multiply by the equivalent amount to move from meters up the scale. Let's put that into practice. So those conversions are kind of built in. So there is one that's not on the chart called a microgram that is going to show up on your homework. I'm pretty darn sure there's a homework assignment that involves the microgram. So a microgram is a millionth of a gram. 1, 2, 3, 4, 5, 6, 7. Yeah, of a gram. And that is not at all uncommon to see medications measured in microgram amounts. I mean, Synthroid, thyroid medications, and a lot of other things are potent enough that they need to be measured in microgram amounts if they're going to be anything even close to whole numbers, just to make your life a little easier. A microgram is not on that chart, but that is one that you will see in practice. I'll guarantee you. So if you, until you have this committed to memory, you can use the following mnemonic, or mnemonics, your choice. So King, Henry, kilometer, hectometer, decameter, pi for base unit, decimeter, centimeter, and millimeter. King Henry died by drinking chocolate milk, base unit being the B, or keep happy daily by doing centered meditation. So if you're a mnemonics person, this will get you by until you have that perfectly memorized. Well, let's convert some units of length to start with. We're going to convert millimeters to meters. So when you're calculating a conversion, what you do is you start with the initial unit that you're asked to start with, and then use a conversion factor to turn that into the unit you're looking for. So we have 25 millimeters is what we're starting with. We're asked to calculate the number of meters that is equivalent to. So we know that we want 1 meter up top. And we also know that there are 1,000 millimeters in a meter. So 1 millimeter or 1 meter is equal to 1,000 millimeters. So you have basically 1. Those are one. That's a 1 to 1. You cross out the units that you don't want anymore. Make sure you're left with the unit that you want to keep, and then just do your math. So 25 times 1 gives you 25 divided by 1,000, and you get 0.025 meters in 25 millimeters. Metric system's not so bad, right? Okay, so let's try one more. So we have 83.6 millimeters. That's what we're starting with. Our conversion is, once again, in this case, 1,000 millimeters is the same as 1 meter. Meter is what we want. Our units are across from each other, so we can cancel those out and basically divide 83.6 by 1,000 to get 0.0836 meters in 83.6 millimeters. So that conversion is pretty easy, okay? And you can do that with any of these, like kilograms to centigrams. You would just go back there and find out how many centigrams are in a kilogram, plug that into the conversion, make sure that your units are going to cross out and that you are left with the units that you're looking for, and then do the math. So once you get really comfortable, you can just convert from any units on the metric system, but we're going to start with the base system here just by moving the decimal point, okay? By how many times you are sliding to the left or the right. So in this case, we have 2,458 grams. If we want centigrams, of course, we're going to have to move the decimal place one place to the right. As you go to the left, you also need to move decimal places to the left. So as you move to the right, decimals go to the right. As you move to the left, decimal also moves to the left. So in this case, to go from grams to kilograms, you want it 1, 2, 3. So that decimal point moves over 1, 2, 3. So the equivalent number of kilograms is 2.58. So you can certainly do it that way if you're comfortable and you're sure, 100% sure that you're getting the number right, so you don't end up with an error like we did in our first two examples. Or you can always just set up your calculations like we were doing above. We have 2,458 grams, and we know there are 1,000 grams in 1 kilogram. Cross out those units, and we're basically dividing 2,458 by 1,000, getting to exactly the same place. Either way is fine. So that exact same thing, if you would have 969 kilograms and you want to convert that to grams, we know that as you go to the right, the decimal point is also going to go to the right. So that is 3 places to go from kilogram to gram. So 1, 2, 3, we get 969,000 grams and 969 kilograms. As you go to the right, decimal goes to the right. As you move to the left, decimal goes to the left, and you just need to calculate or keep in mind where those relative places are on this chart of the metric system. A little more practice with the metric system. So if we have a vitamin C capsule with 75 milligrams, how many grams is that equivalent to? So we're being told we're starting with 75 milligrams. The conversion is, there are 1,000 milligrams in every 1 gram. The units cancel, and then we end up dividing 75 by 1,000 to get 0.075 grams in each 75 milligram capsule. So, metric system, nice, easy, and tidy, which brings us to the US system, which is neither neat nor tidy, but it is the one that we will be using with some frequency. So same basic idea, we still need to convert using a conversion factor between different units. So for instance, we have 3 pounds that we want to convert to ounces, okay? And we look in our book or online, and we find out what the conversion, how many ounces there are in a pound. And we find out for every pound we have 16 ounces. And it's double check, so our pounds are going to cross out. So 3 times 16 is 48 ounces in 3 pounds. Same basic idea. It's just a lot harder to move these, and you certainly can't do the decimal point moving trick that you can, like you can in the metric system. You're almost forced to, at the very least, memorize these conversion factors and do the math in your head. So let's go the other direction with another example. We have 42 ounces. We want to know how many pounds that is. Those 42 ounces. And like we saw above, that for every 16 ounces, we have 1 pound. Ounces cancel. And 42 divided by 16. Going to leave you with a grand total of 6 and 2.625 pounds. Hopefully not too bad yet. Okay, does anyone want me to work any of those examples of pounds to ounces or ounces to pounds? I guess I've already done both of those, example of both of those. Now let's just do this as a review because it looks like they set it up as a fraction. So it's just it'd be kind of fun to do that. So we have 42 ounces times 1 pound over 16 ounces. We get 42/16. Cross those out. Pounds. I don't know about you, but if you tell me to grab 42/16 pounds of something, I wouldn't really know where to start. So let's turn this into an improper fraction. No, excuse me, a mixed number. My bad, got my terminology mixed up. So we know it's 2 pounds, and 2 times 16 is 32. 32 minus 42 is 10/16. So 2 and 10/16 pounds. Of course, we're not done because we aren't simplified yet. So we have 2, and 2 goes into 10 5 times, and 2 goes into 16 8 times. So 2 and 5/8 pounds is going to be a lot easier to work with than 42/16 pounds. Even though technically, yes, they are the same. So you can do the same with fluid conversions. We want to convert 36 ounces. And we look for our conversion factor and find out that there are 5 fluid ounces instead of weight ounces in 1 cup. We want the number of cups. Once again, we'll do it the way they did. So 36 ace cups. Let's convert this one into a mixed number. So 36 divided by 8 gives us 4. And 4 times 8 is 32. Minus 36 is 4 and 4 ace. Simplified. We'll get 4 and 4 goes into 1. 4 goes into 4 once and into 8 twice. So 4.5 cups. It's the same as 32 ounces. Okay, that's a double conversion. That one we don't need to worry about that so much. So are you guys comfortable with American system conversions, more or less? At least the examples I've gone through. Okay, I see some heads nodding. Okay, great. I can always circle back to these if these don't seem to make sense. So we've converted within the metric system. We've converted within the US system. So we also need to be able to convert between the US and the metric system. So here are some handy dandy conversions. Cubic inches to milliliters. Not that useful, honestly. Liters to quarts. That one is kind of a good one to tuck away, and I just say that because it's super easy. They're practically the same. So 1 quart is essentially equal to 1 liter, close enough for day-to-day usage at any point. So that's an easy one. Now 3.79 liters in every gallon, that's a good one to tuck away as well. And I say that because if you go to any other country, that if you see something, if you see gas, if you see at a petrol station, gas is $3, and you're like, oh, that's not too bad. You need to remember that it's actually per gallon 3.79, actually $11.37 per gallon, because it's priced generally in per liter. So $3 per liter is $11.37 per gallon. So I've learned that one the hard way when I was first time I went to Canada as a young man and gassed up my car. Another one that goes 2 more in the weights that you will see in medical practice with great regularity is ounces to gram. There are approximately 28 ounces, no, 28 grams per ounce. That's a common one. Or if you want to if you're able to guesstimate, so about 30 grams per ounce. It will get you in the ballpark. At least you're on the right page. And one that I guarantee you're going to want to know is how many pounds are in a kilogram. And there are 2.2 pounds in every 1 kilogram. So that one, definitely just remember that one, because that one you'll use almost on the daily if you're working in a front office. So let's do a conversion between pounds and kilograms. So we have 125 pounds. They come in, patient weighs 125 pounds. Doctor wants to know how many kilograms that is. So we know there are 2.2 pounds in every kilogram. Make sure those are crossed out. And we divide 125 by 2.2, and we get 56.82 approximately kilograms. Yeah, it's always amazing to me. I do follow weightlifting as a hobby, and in the Olympics, I'll see people put up numbers like 368 kilograms, which is a lot even in pounds to someone like me who's a rank amateur who doesn't take steroids. But when you realize that 368 kilograms over 800 pounds for their total, something they're picking up off the ground, basically picking up a refrigerator and pressing it out over their head. It's crazy. Okay, it's amazing what good genetics and the right chemistry will do. So gallons to liters. What do you want to know for foreign travel? 20 gallons. So there are 3.79. Did I get that right? Yeah. Liters in every 1 gallon. So 20 gallons times 3.79 will give us 75.8 liters. And since it's so important, let's do one more kilograms to pounds. So got a 15-kilogram child in your office. Mom asks how many pounds that is. You will tell her in no uncertain terms that for every kilogram, there are 2.2 pounds. So their lovely child weighs exactly 33 pounds. Okay. So that, yeah, we did that one. We've done gallons to liters, liters to gallons. So we've had practice with everything that you're going to need in this class. And I think, if I'm not mistaken, all the future classes you're going to take in your respective certification classes here. And I never knew what Measurements Jeopardy was, but a liter is more than a gallon. Heck no, it's exactly 3.79 times less. Kilogram is greater than a pound. It is 2.2 times greater than a pound. An ounce is less than a gram. That would be false. There are approximately 28 grams in every ounce. And a teaspoon, where we started on our first page, that mistake was made. A teaspoon is equal to a milliliter. If you remember, a teaspoon is actually equal to 5 milliliters. And that's definitely one that you want to know as well, because a lot of times cough syrups are measured in teaspoonfuls, and you'll have to figure out how many milliliters that you're dispensing to a patient, be they human or mammalian. And that, my friends, is our quick